alley-oop is a pass between two players on the same team. The first player lobs the ball up towards the basket, where the second player has the opportunity to jump, meet the ball, grab it while in mid-flight, and slam the ball home. So to break it down, the first person passes the ball, which looks very similar to a shot, towards the basket, as you will soon see LJ do. After doing so, the second person, Connor, will come through, grab the ball, and throw it down the hoop. It looks very nice and aesthetically pleasing. For the passer, he must first get the ball to its destination. He does this with the ideas of projectile motion. With knowing the weight of the ball, he can calculate the speed he must throw it and the angle at which to do so, so he can properly measure and calculate where the ball is going to fly. This allows for a great pass and a great alley-oop. After the pass is where we see the real fun. With Newton's third law, it states that each action has an equal and opposite reaction. As we see here, Blake Griffin, to produce enough force to jump up and catch the ball, must produce 700 pounds of down force, which is equal to 700 pounds of up force, which propel him away from the earth and up towards the ball. This is the same with all people that are dunking, maybe just a little less pounds. And not only the pass, but as well as the dunk, we see the importance of projectile motion. In this diagram, we see the events and physics that takes place in a projectile motion equation. Vx is the velocity along the x-axis, Vxo is the initial velocity along the x-axis, Vy is the velocity along the y-axis, Vyo is the velocity initially on the y-axis, g is the acceleration due to gravity, and t is time taken. These all are huge factors in projectile motion. All these equations also play a large role. The horizontal distance, the horizontal velocity, vertical distance, and vertical velocity. These will all play detrimental parts to the alley-oop, the dunk, and really all parts of any sports that have to do with balls or jumping around. And these equations of time of flight, maximum height reached, and horizontal range, v is the initial velocity, sine is the component along the x-axis, and cosine is the component along the y-axis. We can see this in distance and time, which are both huge components. In calculating the time needed to dunk the ball, we simply plug in the formula. The initial velocity of 10 at a 50-degree angle divided by gravity would give us a necessity of 1.657 seconds in the air. To dunk is not only getting to the basket, but getting high enough above the basket that while holding the ball, you can still slam it down the net, which as we can see is about 10.6 inches. Now modern day basketball players have no problem, but it's different for us. The greater force down creates a larger force up, which enables someone to jump higher and further with a higher initial velocity. The angle also plays a key role, especially when trying to get over the basket, not under it. Newton's first law comes into play when he states that an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted on by an unbalanced force. The passer's job is to put the ball up near the basket, and the dunker's job is to be that unbalanced force and redirect all the energy and momentum back towards the hoop. We also see Newton's third law in play here because he feels the same amount of energy exerted on him as he does when he catches the ball and stops it.